Welcome to Khetz tutorials, and in this video I'll be covering question 59 from D exercises in geometry calculus. So given sine x equals 1/3, sec y equals 5/4, and we're told that x and y lie between 0 and pi/2. So in the cos diagram or unit circle, it's between this point and that point. And here both x and y are positive, and we're asked to evaluate this based on the given information. So focusing on the angle x on this side, remember that your sine is y/r. So in this case, in terms of your coordinates, y is 1 and your r is 3. And we can find x, and this x is not the angle, so don't confuse it with the angle. It's just an x coordinate. So x squared plus y squared equals r squared, and this is the Pythagoras theorem. And that x can be found this way. Our r is 3 squared, and this is 1 squared. So this is 9 minus 1, which is 8. So our x squared will be 8. Then here, our x would be plus or minus the square root of 8. And because we were told that x and y are between 0 and pi/2, in this region, we know that the x is positive and the y is positive for both angles, so the angle x and the angle y. So we're going to take the positive one. All right. Then, using this, we can now evaluate cosine and sine, which we need for this. And we need it because to solve this, we're now going to split this into its compound angle. And this is what it looks like. So we're going to substitute sine, and we now have the y and the r, which correspond to the angle x. And if we look on this side, so sec is the reciprocal of cosine, we have enough information for cosine of y, but not enough information for sine of y. So to complete that information as well, we're also going to find y. So we're now going to shift our attention to angle y. And here we're going to find the y coordinates. So sec is the reciprocal of cosine, which means this is the same. So cosine is x/r, so this is r/x. So r is 5 and x is 4. And we're now going to find y using the Pythagoras theorem once again. And our y is r squared minus x squared. And r squared is 25, so 5 squared. And 4 squared is 16. So now I have y squared equals 9. So our y is plus or minus square root of 9. And we know that y is positive, so you can take the positive one, which is positive 3. So now I have enough information to substitute back into the compound formula. So let me just write it down here so that we can continue here. So we want to evaluate sine of x plus y, and we know that sine of x plus y is sine x cosine of y plus sine of y cosine of x. All right. So sine of x will use the coordinates which are related to the angle x, and sine is y/r. So the y that corresponds to x is 1 and the r is 3. Then cosine of y will use the coordinates that correspond to the angle y, and cosine is x/r. So the x there is 4, and the r that is on this side, or that corresponds to that angle, is 5. Then we're going to do the same for sine y, which is now on this side. So the y is this one, which you just found, and the r is 5. Finally, we have cosine of x. We're going to go back to the angle x. And cosine is x/r. So the x is square root of 8, and the r is 3. So we now just have to solve this, and that will be our answer. So if you work this out, this will be 4 over 15, and this will cancel that. So we're going to have square root of 8 over 5, and we can find the common denominator of these two, which is 15. That brings 4 there, and at the top, we're just going to multiply square root of 8 by 3. And square root of 8 is the same as 2 square root of 2. So this can be as follows. And ultimately, you have 4 plus 6 square root of 2 over 15.